Welcome to Jeffrey. My name is Hazid bin Harudin. My matrix number is S25B0630. Today, we from Group 4 are going to be presenting about project solving X equal B analytically and iteratively. So this is our group member names. Right. So I do part 1. So part 1 is data generation. So the question is, consider a system of linear equation Ax equal B, where A is a 3 by 3 real matrix, X is unknown 3-dimensional vector, and B is another 3-dimensional vector. So the first step I need to do is construct a set from student ID. So the part 1 is collect the last 4 digits of the student ID of all the members in my group. And then I need to interpret each last 4 digits block as integer. For example, if 3 students have ID endings with SX, YY, ZZ, then I need to obtain 3 integers. Then I need to compute the seed value. And lastly, I need to clearly state the ID, use only last 4 digits, show the calculation of S, and record the final numerical value of seed. So this is what I do. This is the Python coding that I have right. So the first thing, we need to import the numpy SNP. So the numpy is the function to use vector and matrix in the Python. So I declare a variable named num, which is integer, to store a number of group members. So members is the store to store the data I enter in the first line, which is num. Okay, for part 1, in the range num, student ID, input enter last 4 digits of the student ID. So when I enter the number of group members, let's say 7, this line will repeat 7 times. So I need to enter the student ID for 7 times based on my group members. So then it will print the input that I have entered. Then it will calculate the seed, which is the sum of the student ID. And then it will print the calculation calc plus join, which is bin. It will show the student ID plus the next student ID until I have the final seed value, which is seed. So this is the output if I do if I run the coding. So the first thing, it asks how many group members I have, which is 7. Then I need to enter it 7 times. Then it show each student ID members. Then it show the seed calculation. This is where the joins work. It show the plus. And finally, the final seed value S equal to the sum of the calculation of the student ID. So this is my part for the part 1, right? So then I will pass it to my friend Fawaz for the part 2.
Assalamualaikum to Sir Jeffrey. My name is Muhammad Fawaz bin Azhar. My number matrix is S25B090659. Today I want to present for step 2. For step 2, we generate a 3 by 3 matrix A and a 3 by 1 vector B using Python in Google Colab. We set a seed value so that the results are reproducible. Next, we check the determinant of matrix A. If the determinant is 0, the matrix is not invertible, so we increase the seed and generate a new matrix. This process continues until we obtain an invertible matrix. As shown in the output, the determinant of matrix A is not 0, so the matrix is invertible and suitable for further calculations. Thank you.
Assalamualaikum. My name is Aiman Hakimi bin Ahmad Zarizi, and I will be presenting for part 2A, which is called Analytical Solution of AX equals to B. So for part 2A, it is very simple. Just rewrite the matrix equation AX equals to B as 3 simultaneous linear equations in terms of x1, x2 and x3. For part 2a, I will be using Gaussian elimination because it is very simple. So first I will rewrite augmented matrix, then perform elementary row operations to eliminate variable step by step. So what I would like to do is I will make sure x1 from row 3 is equals to 0 and x1 from row 2 is equals to 0 and finally x2 from row 3 is equals to 0, and then we will simply find x3 later. So for part A3, which is what we call back substitution, from last equation I solve for x3, then substitute this value into the second equation to find x2, and finally substitute both values into the first equation to obtain x1, and we will find the answer for part A4. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Lokman Abdulatif, and I'm going to continue part 2B, Python verification of analytical solution. For part 2B, using Python in Google Colab to verify that the analytical solution obtained at least satisfies the linear system AX equals B. For Python-based verification, I'm using X. First, I compute the solution vector X using the function X equals np dot linear algebra dot solve bracket A and B close bracket. We solve the system of linear equation directly. Then I multiply the matrix A by the compute solution X using A multiply X to obtain AX. And for the B2 is a code when evidence of correctness. From the output, the computed solution vector X is 0.833, 0, negative 0.916. When AS is calculated, the result is negative 3, and 5, which exactly match the original vector B. As an additional numeral check, I use the function np.all close bracket AX and B. Sorry. The output is true, which confirm that AX and B are equal within numerical tolerance. Explanation. In summary, Python successfully compute the solution vector X. Recomputing AX reproduce the original vector B. The NP close verify to confirms the correctness of the solution. It's true. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izrajimi bin Abdul Majid, and my numbers matrix is S25B0639. Now, for my parts, I will present about using Jacobi iteration method in this problem. First, C1. As you can see, we need to set up the Jacobi iteration sim operation for the specific matrix A and vector B. First, we already have matrix A and vector B. This is matrix A, then this is vector B. First, we need to rearrange the each variables so it can be expressed explicitly. First, for the x1, we use for the x1, we use the first equation. First, this is x1, so we use the first equation. So the 3 need to for the 3 we need to move to the left. So as you can see, it will be like this. And for the second equation, we need to use x3. We can find it is because in the third equation, there is no x3. So x3 we need to use the second equation, and the third one we use for the x2 variable. That's how it will be. Then next, starting from x0, computer several equation approximation by hands. So we need to use Jacobi methods. So begin with the x0, it's the 0, 0, 0. For the first interaction, the this is how we do the first equation for x1, 0, x3, where the variable we replace with 0 because x0 equal for 0, 0, 0. Then we just calculate normally. So from x1 we got -1, 5, and 0.75. For the x2, we replace with the x1, x2, and x3 with the variable we get from before. As you can see, for the x1, we use 0.75. It's from the variable x3. And 5 we got from x2. Remember from the previous one, this one x2, x3, this one x1, x2, and this is x1. We use the previous one to replace to the new one. We do it until you want to stop. So I'm just do it from x1 to x4, as you can see. Then next, show the calculation for the list. Okay, this mean we show it on the table. So this is the table that show everything clear and variable change every interaction to the next. First the 0 1. The 0 1 obviously we replace it with 0, and this is the x, the the second one. As you can see from the previous one, we got -1, 5, 0.75. So we replace it here. And we do it until it look like a table, show it clearly and neatly. So the last one, it show it say indicate how you judge whether the interaction are sufficiently close to the analytic solution from part 2. So that means this is we need to see, so we need to judge if this method is convert or does not convert. So as we can see, it give from variable from the so we need to see a difference between the x560 -11 12 with the answer we got from the solution. So as you can see, first the second one it says 0. So as you can see, there's no this is no 0 in here. So I will just take the fourth interaction. So as you can see, that does not match. Does not match even this one. So the answer for this question is Jacobi method does not convert, because from the x0, as you can see this one, to the x4, the number keep increasing, does not even close. So the answer is Jacobi method is not converge. That's all from me. Thank you.
Assalamualaikum. My name is Aidil Nazran bin Nordin. My number matrix is S25B0667. For today, I will explain for part 3B. For part 3B, we implement the Jacobi iterative method using Python in Google Colab. We start with initial guess x0 equal 0, a tolerance of 10 minus 6, and maximum of 50 iteration are used as the stopping condition. In each iteration, we compute a new approximation of a solution using the Jacobi update formula, where each variable is calculated independently. Using value from the previous iteration, after each iteration, we calculate the infinity norm of the difference between two consecutive iterations. The iteration will stop when this error becomes smaller than the tolerance as shown in output. The stopping condition is met, which indicate the method has converged. Next, we compare the Python-based Jacobi result with the manual Jacobi iteration. The result are consistent and show the same converged behavior. We are also compare the final Jacobi solution with an analytic solution obtained using a direct method. Both solutions are identical up to numeric precision with difference on the order of 10 minus 16, 10 minus 16. Finally, we compute the residual a x and b. The infinity norm of residual is very close to 0, which confirm the accuracy of solution. In conclusion, the Jacobi method converges successfully and agree with both manual iteration and the analytic solution. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Umar Hakim bin Nizam. Number matrix S25B0664 from Group 4. I was tasked by my friend to compile all of their work to one report, and today I will show you how the system runs. Okay, first we go to our Google Colab. As you can see, I already copy and paste the code in here. So we just need to run it all. Okay. Okay, first we need to enter our team. We have 7 people, so I put 7. Okay, and press enter. Okay, then I will put the last digit number of the matrix card. As you can see here, we have the list, so I will copy from this list. First, first is 0639. Enter. 0664. Enter. 0659. 0630. 0691. 0667, and lastly 0658. Okay, and enter. Okay, as you can see, the output are like this. Okay, for this view, for this the part 1 of data generation. As you can see here, data generation part 1. This is the outcome. And for the second part of data generation, this step for generating A and B are this, where matrix A and vector B, and that's A. Okay, then we move to our second part is Python verification of analytic solution. As you can see, this is the code for this part, part 2B. Okay, as you can see, this is for part 2B, the computed solution S and computed AS. Okay, for part the second part for part 3B, Python implementation of Jacobi method. As you can see, this is the code that we use for this part. Okay, the outcome this. Wait, you can see. Okay, these are for part B Jacobi iterative method. As you can see, this is the outcome for them. These are for comparison with manual Jacobi interaction, and this for the comparison with analytical solution. Okay, and this is for the conclusion. Jacobi method covers and agree with this analytic solution. Okay, that's all for the code and the outcome. As you can see, all the code are working perfectly and showing the correct outcome. So that's all from me. Thank you.